Okay, here's an interesting paper that came out last week. Vibe Coding Flow-Based AI Development by Andrej Karpathy. And here's why it's kind of cool. So this is one of those papers that solves a problem that pretty much no one had actually thought about. So the paper starts with this basic idea that building software is hard. Like it's very expensive, time-consuming, error-prone. And as a result, it's often kind of the bottleneck in a lot of applications. So if we could just build software faster, well, then we could basically build more software. And along those lines, the core insight of this work is that programmers spend a ton of their time implementing low-level details. Basically getting the syntax right. If you're a programmer, you know exactly what I mean. It's not the fun part. The fun part is like building the system. The fun part is thinking about algorithms and data structures and all that stuff. But a lot of the time you have to implement these low-level details just to get the thing working at all. And so if we could delegate that to an AI, that would be huge. So how does this work? Well, it's really simple. It's just 3 steps. First, you write some high-level description of the functionality you want. For example, in Python, you might have a function called maybe something like setup board or initialize board. Takes an integer n by n, creates an n by n matrix of zeros. That's it. That's the input. You describe the functionality you want. The second step, you use a large language model to implement the bulk of the code. Now note that this implementation is not perfect. There are definitely bugs in here and we'll talk about that in a moment. But the key point is that it's almost done. You don't have to worry about like loops and variables and what's going in and out of the functions and that kind of thing. It's just about refining this implementation to make sure that it works. And third, you check the results, see if there are any errors and correct them. And the cool thing is that after a few rounds of this, you can build up some fairly complex functionality really quickly. I think this is a pretty good example. So you start with this basic idea of a tic-tac-toe game. You create the board, you set it to empty. Then you describe a function that checks whether the game is over and you do this again and again and again. At each step, the AI is filling in a bunch of the details. It's making a lot of the mistakes so that you don't have to. And you just refine the code until it's basically perfect. Now look, this is not a complete system, right? It's not like you can build an entire application just by describing it in English. Not yet anyway. But this is kind of the first step towards that kind of system. And what's also interesting is that this technique can actually be applied recursively. So for example, here's a situation where they have a bug in the code. The algorithm for finding the winner is not quite right. Okay, you can fix it manually. But another thing you can do is you can ask the AI to debug this code and it can find the bug and fix it. And then you can apply this whole vibe coding thing to the debugging AI. So it's almost like a meta vibe coding thing. It's kind of crazy. I haven't seen this before. And if you think about it, this makes sense. After all, the ultimate origin of most bugs comes from the fact that humans don't understand the code base perfectly. So it should be possible for an AI to look at your code and figure out what you meant and fix it up for you. Kind of cool. Now, of course, like everything else in AI land, nothing comes for free. This has a couple of downsides. First of all, speed. As they mention in the paper, this is not fast. It's not production ready yet. Getting human-level proficiency in programming languages is still a long way off, and it's not clear how far this can be scaled up. We saw with Copilot that even for relatively simple tasks, the AI can get pretty confused, and I suspect that this will be even more true when we're talking about larger scale projects. But ultimately, I think this is just a matter of scaling up the models. This isn't a fundamental limit. It's not like physics or something. We just need bigger models. And given how quickly AI is developing, I wouldn't be surprised if something like this was being used in production within a couple of years. But I think the other major downside of this work is that it's not open source. They only released the models and the pre-trained weights for Python. And that's it. And the reason for that seems to be mostly legal. Most of the code examples in the paper are taken from like GitHub repositories that have commercial licenses, which means that Andrej probably can't release the trained models without violating those licenses. And unfortunately, because of that, you can't really reproduce any of the experiments in the paper. You can't even try it yourself. Like they have some demos on Hugging Face, but they're very limited. All you can really do is use the Colab notebook that they provided, which is fine. But it would be nice to be able to play around with this yourself. Anyway, I just wanted to highlight this work because I thought it was pretty neat. I think it shows the power of these large language models in a different context. than we normally see, and I think it has the potential to be a really useful tool. If you like this video, you might enjoy the channel where we talk about all kinds of AI stuff, including my favorite, which is AI for science. So we talked about this paper on a website. And now we're going to do something new. We're going to turn it into a video format. So this is our first ever AI explained video. It's a little bit different from the normal style. It's a little more casual and it's got a little more of the personality of the author, but we're trying out a new format. So let me tell you a little bit about it. It's basically a video version of Wikipedia, except it's not quite that simple. You see, Wikipedia is great, right? It's easy to read, it's accurate, it's up to date, but it's static. It's kind of like a snapshot in time. It doesn't really capture the dynamism of the internet. It doesn't have the comments, it doesn't have the discussion, it doesn't have the memes. And it doesn't really reflect the way that people actually use the internet. AI Explained is like a video version of Wikipedia, but with all that extra stuff. So every article has a bunch of related videos that are linked throughout the text. So you can click on them and watch them. And then there's also a discussion section where you can leave your own thoughts, or read what other people are saying. And there's even a little community tab where you can vote on what articles you want to see next. We're launching with a bunch of articles on topics like artificial intelligence, neuroscience, philosophy, psychology, and a bunch more. And we hope that you'll find them useful. So go check it out and let us know what you think.